Hi there, this is your favorite non-Indian math channel, and I have an infinite sum problem for you. So let's see how we can do it. Well, in general, if I want to solve a sum with ln's, it would be nice if I have something like ln of n minus ln of, let's say, n minus 1. Why is that? Because this is just multiplication. So I mean, it's just recursive, and everything will just cancel out. But except I would have it, I could also just write it like n over n minus 1. So basically, I want to prefer that everything on the ln, if I can write everything just as multiplication and division, it would lead me as an answer that looks like this, and it will just cancel. So let's work with this inside and see if I can just write it like multiplications and divisions. So I have, let's call this thing a. So I have ln a for the question. And so it's gonna be 1 plus, let's just multiply it, and it's gonna be 3n squared plus 4n plus 1 over this thing. Well, I can factor the denominator easily. It's just n times 3n plus 4. And for this part, so let's look for some roots. Well, yeah, I can just separate it like 3 and n and 1, 1. And if I just multiply them like this, it holds. So it's just cross. Well, here it doesn't matter, but in general it does. So it's going to be n plus 1 times 3n plus 1. Okay, cool. So I have n plus 1 and 3n plus 1 and 3n plus 4. I kind of should group them like this because they have like different similar characteristics. So I'm gonna call this sum S. I don't know if it's convergent, but we will see. And I'm gonna define sk, which is if I add k terms instead of just adding up to infinity. So it's gonna be n from 1 to k of this thing, which I found that it's ln. And let's actually write them with simplified form. So from the first two, I'm just going to write this thing as ln of n plus 1 minus ln n. And here I have just plus ln of 3n plus 1 minus 3n plus 4. I can write it on a different summation. K is from 1 to n, ln 3n plus 1. Sorry, my cat is attacking me. Minus 3 ln 3n plus 4. Okay, cool. So here, well, this part is quite obvious. Let's write first this part. So if I put n is equal to 1, it's going to be ln 2 minus ln 1. If I just continue, let's write one more term. If I put n is equal to 2, it's going to give me ln 3 minus ln 2. So let's call this part like b and this thing c. So, and let's just delete this thing. So b is gonna be like this, ln2 minus ln1, ln3 minus ln2. So all of these terms will just cancel, and in the end I'm gonna have ln of n plus 1. So it's going up to here, ln n plus 1 minus ln n. So this ln n will also cancel, and b is gonna be equal to ln of n plus 1 minus ln1, which is 0. So b is equal to ln n plus 1. But sorry, here I'm adding up to k. So these ones are actually k plus 1. And this is ln k. And so this should be ln of k plus 1. Sorry about that. And now, so I found b. C is a little harder, but it's same logic. So here what I can do is I can either just put k is equal to 1 and 2's, and it will just give me the same, or I can just factor out an ln3, because if I rewrite the c, it's gonna be sum. So this thing is just, or let's just write it here and then I will write without summation. So this thing is literally ln of 3 plus ln n plus 1 over 3. So I factored out the 3 and I write it as summation. And this one is just minus ln 3. And this is of course again minus ln 1, sorry, this is not 1, n plus 4 over 3. So either I can just do it like this or like this. Here I will have only these things. But it's basically same, and we can just go with this one. So when I put n is equal, k is equal to 1, sorry, this is again wrong order. So this is n from 1 to k. When I put n is equal to 1, this thing is gonna be ln4 minus ln7. If I put n is equal to 2, it's gonna be plus ln7 minus ln11. So it's gonna be 6, 10. So it's just gonna go like this, and this time I'm gonna have canceling like this. And if I go till last step, which is n is equal to k, it's gonna be ln 3k plus 1 and minus ln 3k plus 4. And so it's crossing like this, so this will also cancel, and c is going to be equal to ln 4 minus ln 3k plus 4. Okay, cool. So and now I can just add b and c. So it will be like b plus c is gonna be equal to, so I'm just adding them. Let's write ln4 separately, or I'm just gonna multiply everything. So I have ln 4 k plus 1, and this one is just 3k plus 4. So this is a big ln again, and so this is equal to sk, like how we defined here. I said this is b plus c is just sk, and I know that my infinite sum is gonna be equal to, if I take this k as limit k goes to infinity of sk, is gonna be equal to my sum, which was ln of a, again all these letters. So let's just show it s. So s is limit as k goes to infinity sk, which is, so then I don't need to write this thing. And so this is going to be equal to, if I just take this limit, ln is continuous function. So if I take, let's write it, limit ln something is going to be equal to ln limit something. Okay, this is because ln is continuous, and therefore, so it's just going to be limit of this thing, 4k over 3k is just going to be 4 over 3. So it's going to be ln of 4 over 3. So this limit is 4 over 3. So this limit is ln of 4 over 3. And therefore, this is my answer. We can also write it like ln 4 minus ln 3, which doesn't make it look simpler.